last time that we do a unit circle quiz. Oh, I'm sorry, people. That's the first thing you heard on this video.
Oh. I did the 7, 6 because I put 6 7. Oh.
What, really?
Alright. What did we finish class doing yesterday? We have to do some math.
Oh, I reversed it.
I'm sorry, dude. We might have time at the end if you don't go outside. Okay. Identities. We done? Yes. Yeah, what was the Pythagorean identity? Oh, please no. There we go. How do we say this? Yep, keep going. Bench, forward. Sine squared theta plus
Theta equals 1.
Yes, so that was our first trig identity. We're going to learn a lot more probably in the next unit, in unit 8. Okay, but for right now, we're going to look at the reciprocal trig identities. Reciprocal trig functions, not identity, functions. So what are our 3 main trig functions? Yep, sine theta, which equals what? In our unit circle, what does sine theta equal?
Y.
Y, perfect. No, y. Yeah, okay, cosine theta equals what? X. And then tangent theta equals what?
Y over X.
Perfect. So those are our trig functions. We're going to graph those very, very soon. Those functions right there. Because there's 3 more of them. And that's the reciprocal of these. So, I'm going to tell you what they are. First off, sine. The reciprocal of sine is called cosecant. You're thinking of inverse sine. Yes, this, instead of sine, this is 1 over sine theta. Yeah, okay, actually don't write 1 over sine theta yet. Okay, secant. Know how we did sine, cosine, this is tangent, and we shorten them? Okay, shortening cosecant is written as SSC. So, CSC. Theta equals 1 over sine theta. So we're putting everything in the denominator. So, Benj, if sine theta equals y, what does cosecant theta equal?
Sine.
What does sine equal?
Equals to y.
Equals to y. So all we do is do this. 1 over y. Yep. So cosecant equals 1 over y. Okay. So that cosecant is the reciprocal of sine. Now, the next one we have is secant. And we shorten this down to SEC of theta. And what do you think that's going to equal? Same. What do we think secant is going to equal if it's the reciprocal of cosine? Yep, 1 over cosine. And then Wenzel, cosine equals what? Yep, 1 over x. So secant equals 1 over x. Now, we got one more. Our last one is called cotangent. Yep, the reciprocal of tangent is cotangent. And we write this as COT. It's the first three letters in this one. First three letters in this one. This is the only one that's not the first three letters. It's the C, the S, and the C. I don't know why they decided to skip it. Oh, I know why I skip it. Because if you took the first three letters, it's cosine. So they did that. Okay, sorry. Back to cotangent. So this is 1 over tangent. Let's not write the whole word. Tangent of theta. So what does this equal? So tangent of theta equals y over x. So I'm doing the reciprocal.
1 over y over x.
Okay, so then let's keep change flip this. So keep, yep, which equals x over y. Yep, so cotangent equals x over y. Yep, exactly. So, cosecant, I'm just going to write it again so it looks a little bit nicer. Cosecant of theta equals 1 over y. Secant of theta equals 1 over x. And then cotangent of theta equals x over y. This one equals 1 over sine theta. This is 1 over cosine of theta. And then cotangent is 1 over tangent of theta. So those are the three reciprocal trig functions. Right there. And that actually ends 7.2. Yep, we've done 3 days of 7.2. So your homework for tonight is homework 7.2, page 361, do 21 to 31. All, yep. Well, it's not due until Monday. This homework. Today's Thursday. I won't have you tomorrow. I'm so sad. On Monday. Monday. No, Monday. Everyone's going to be back on Monday, remember? Yeah. They all come back on Monday. I'm pretty sure. As long as the plane gets in. Who?
Oh, the players.
When they stay there for 2 weeks? Yeah. I didn't know that. Wow.
Wait, why?
I should have gave them more work to do. Okay. Well, all you people doing NYL, good for you. Guess what we get to do next? We get to graph these guys.
Oh.
Graph him. Yep. We are graphing these next. So we are in. You're gonna, yeah, I don't 100% like these. But you only have to graph them once, and then you pretty much remember them. Okay, 7.3. That is next. 7.3 is graphing. Graphing. We're only going to graph sine and cosine for this one. Cosine functions. Those are the only two we are graphing. Now, there's something special about our graphs. When we're graphing this, our axis, written as such, this is always y, this is always x, right? Yep. Okay, this x, no longer x. It's actually going to be theta. So it's in radians. We're going in radians. Could also be degrees, but we're going to do radians. Yeah. Okay. So let's start with sine. So y equals sine of theta. Okay, let's pick some points. Let's do a 3-column chart. We might not need all 3 columns. We'll see. So I have theta over here. Then I have sine theta. And actually, then I guess we'll do y. Okay. What thetas do you want to use? Okay. We're in a unit circle. Radians. Give me what radians you want to use.
0.
Okay. 0. What are easy ones, guys?
30, 6 pi, 90.
Okay. You want to do pi over 6?
Pi.
We'll use pi too. But I want to show you something.
1 pi.
1 pi. What are my nice clean points on this unit circle?
1 pi.
Over 3.
What are the easiest points?
Pi 2. Pi.
Pi 2. Okay, up here. Yes, 0, 1. 0 or 2 pi. 1, 0 is a nice one. Just pi is also good. Negative 1, 0. And also down here. 3 pi divided by 2. Those are nice clean points, okay? We're going to use some of those nice clean points. But we'll stick with also pi 6. Let's do all the first quadrant too. Let's also do pi fourths, pi thirds. I'm going to need so much more room than this. Then we're at pi halves. Then I'm going to skip some. Then we do pi. I'm just going to scooch down by this point. And then we're going to skip to 270 degrees, which is 3 pi halves. Then, Wenzel, what's our last one we should put? If I go all the way around, how many radians have I gone? Yep. So in terms of pi. What is my circumference of a circle? If I'm here, and I go all the way around, how many pi's am I at? That's degrees. Yep. Okay, I went from here to here. How many pi's did I go? 1. Okay, now keep going. How many is that? 2. Perfect. 2 pi. Alright, 2 pi. Okay, now we gotta plug these in. So, sine of 0. What does that equal? At 0 degrees, what is sine? 0, yep. Okay, what is sine at pi 6? You can use a unit circle. Yeah.
3 pi over
3 pi over 2, yeah. Right down there.
3 pi over 4.
No. We're gonna, from here is quadrant 1. This is all of quadrant 1. And then this is at 180, because I'm skipping now. Because we're gonna use our nice points. This is 270, and this is 360. So I skipped a few. Because you'll see. These are easy points. Okay. At pi 6, what is sine? Yeah. Okay. Benj, what is sine at pi fourths? Perfect.
Oh.
Yep. Yell. At pi thirds, what is sine?
5 6.
Yeah.
The sine is 1. It's squared
Yep.
over.
Perfect. Okay. Wenzel. At pi halves, how much is sine? Oh, what is sine? At pi halves, so I'm at 90 degrees right now. What is the x value at 90 degrees?
Oh.
Yeah. Mhm. Okay. You at pi halves, right? No, you're there. Your pi halves, yeah. What is the x value of that coordinate? No, what's the y value of that coordinate? No, he's got it.
Yeah.
You got it?
Over 2.
Yeah, so at pi over 2, now go to the coordinate, which is like the parentheses.
The x and y. What is the y there?
Oh.
1, perfect, 1. Yes, okay. At pi, what is the y coordinate, Wenzel? Now go to pi.
180, right?
Yep, so what is the y coordinate there? 0, perfect. Jade, at 3 pi halves, what is sine? -1, perfect. Benj, last one. At sine of 2 pi, where am I at? 0, perfect. Okay, let's graph these guys. Okay, what is my highest point on y? And what's my lowest point? Okay, those are the only two I'm going to put there. -1. Perfect. Okay. My first point is 0, 0. So, right there. And I'm going to label this. This is going to be pi half. This is going to be pi. This is going to be 3 pi half. And this is going to be 2 pi. Okay. What's my next point? Where should I be going? Yep, so it's like roughly right there. I'm going to go about halfway. And then I go over a little bit more, pi fourths, and I go up to about like right there. Then I go over a little more, and I go up a little more, about right there. Now at this coordinate right here, this is my nice easy coordinate. So I'm at pi halves 1. So pi halves, and I go up 1. Boom. There we're at. Yeah, where's my next point at? So I'm at pi 0. Alright, tell me when I should stop at pi. Okay, should I go up or down?
No.
No. Okay, staying right there at that point. Okay, what's my next point? Anybody? Yeah.
It's 3 pi over 2.
Okay, so tell me when to stop. Okay, and should I go up or down?
Down.
Okay, tell me when to stop. Perfect, right there. Now my last point is at 2 pi 0. So I'm ending right there. Okay. I want you to connect all your points. See what you get when you graph them. Connect all your points. This is based off of a circle, right? So should all lines be pointy or be curvy? They should be curvy 100%. Okay, so this should all be curvy. So let's start. We go up, 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 up. Then we go back down. Then we switch directions. Blah, 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 blah. And it should look like that. That is our sine graph. I wish I could graph it more. Now, Ben, could I just keep going around the circle over and over and over again? Could I keep going to like 3 pi and 4 pi? Can we?
Yeah, okay.
Yeah. You can,
You can go into infinity.
Yeah.
Because you're going in a circle.
yeah. So I could keep going with my graph. So it could look also like this. Draw this as well. And if I can go in the positive direction, remember my coterminal points and I was going in the negative direction? And I was going like clockwise around. Oops. I was getting my coterminal points and I was going in the negative direction. Yes? No? Maybe so? Yeah? Okay. So I can also go in the negative direction as well. I'm just going to try to figure out how I should plot these. This would be about pi. So I can also go in the negative direction. Oh. That would be the point there. And up. Now I stopped for this from going from here to here. Because that was how many times around the circle? Once. That's also called a period. A period around the circle. We're going to define this later. But we said that for y equals sine of x, which we just graphed, the period, oh my god, was 2 pi. 2 pi. That's how long it took us to go around the whole entire circle. This is, so we just graphed y equals sine of x. It could be like sine theta. I just replaced theta with x. So this could also be theta. I'm just going it back to x and y. So period was 2 pi. A complete cycle of sine was 2 pi. We'll define this a little bit more later, but we're definitely going to use this fact. Now, do we have any questions about how we graphed sine? No.
We said sine. Also use the right? Like we don't. Sometimes we don't use the one in the or
Use what in the unicycle?
the. I mean, do we only use the?
Well, like if we said pi fifths, that would be like right here. The points are there. These are just the nice points. Because like all the other ones are going to be decimals and like long decimals. These are the nice points on the unicycle. And we get enough of them. Okay, so we did sine. So what is next? Cosine. Yep. So let's move it down and erase whatever this is on this page. Okay. Next one, y equals cosine of theta, which we can also just write as y equals cosine of x, but we're going to do radians for a little bit, so that is fine. Do you want to do a 2-column or 3-column table? So 2-column would be skipping this middle step right here. What? Yeah?
The
Say it again?
it's
No, going outside? What?
it's like they were the same, the column 1 and the column 2. You just have to put that sign.
Yeah. So you just want to do 2 columns? 3 columns. Okay. We're going to do 3 columns. Sorry, there's a lot of things I have going on. Okay, so we have theta. We have cosine of theta. And we got y. Okay, let's pick our nice points only. Okay? So what are our nice thetas?
The one that you
Yeah, so 0, it's at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Because those are all on our axis. So what is theta at 0 degrees? What's theta at 0 degrees?
1.
What is theta? 0. Okay, yep. Well, what is cosine? Cosine at 0 theta? 1. Yes, thank you. Okay. At 90 degrees, what theta am I at? Or radian? 2. Pi halves. So what is cosine of pi halves? What's that point? 0. Yep. Okay, next one. 180 is what in radians? Pi, yep. So what's cosine of pi? -1. Cool. 270 degrees, Benj. What radians am I at? 3 pi over 2. So cosine of 3 pi over 2 is what?
0.
Yeah, 0. See, these are such easy, nice points. Okay, last one. I'm back at 360 degrees, so I'm at 2 pi. So cosine of 2 pi is,
0.
yeah, 0. Perfect. Now let's graph this with 1 period and then just add on to it. Okay. So we just went a full circle around. So we just went one full cycle. Okay. Oh, wait. Wait. Yeah. That's supposed to be 1, Renzel. 1 down there. 1. Because my x value there is 1. Yeah. So my highest number is 1. My lowest number is -1. And let's do these the same again. Pi halves. Pi. 3 pi halves. And 2 pi. Okay. Benj. I'm at my origin. Where's my first point gonna go? Which direction?
Up.
Up. Yep, right there. Okay, where's my second point if I start at the origin? Pi halves. And then what? 0. Okay, stop right there. Okay, Wenzel, where's my next point? Perfect, right there. Then my next point is at 3 pi halves, 0. And my next point is 2 pi up 1. Okay, remember, it's supposed to be curvy. How would you connect these points? Let's see, I want to see it. It's supposed to be curvy though. Because it's the circle. We're graphing the circle just on a graph, not in a circle shape. Curvy like a circle. Sorry, that's fine. So this is a circle, right? So I kind of, that's my curve. And guess what? I'm going to go like this. So it's like the bottom half of a circle. And then it's that top half. So this top half, and down to there. So this is relatively the shape of cosine. Or Jade, how did you draw it? Ah, you got it. Okay. What's up? We're gonna graph it up here. Let's connect these points. So it's kind of like I have the first quadrant of my circle. Yeah. Yeah, go ahead. Wait, can you change your graph so it looks like this before you leave? It looks like this? Make this line, look at, see how it curves down like that? Yeah, make it curvy like that. I'm gonna back it up one more. Boom. So that is cosine. That is one cycle of cosine because we went all the way from 0 all the way to 2 pi. Yeah. So this is also period. A full cycle was from 0 to 2 pi. So again, I could have also gone in the negative direction. This would just be in a different cycle and outside of our cycle. But I could have kept going in this direction and it would have looked something like this. And I can keep going forever in both directions. So in Zell, I'm going to extend this one too. Do you want to extend it with me? What do you want to go up to? Yeah. This one would be 3 pi. Yep. And if I kept going, it would go up even longer than that. But this would be 3 pi fourths. 5 pi halves. Oh my gosh. And this would be 7 pi halves. So if I kept going in this, I'm going to still keep the same pattern. Going down, then up. Then I'm going down again. I'm going to keep going. And I'm going back up. And I could keep going on and on forever. Because I can keep going around the circle on and on and on and on forever. But this is roughly my cosine. From here to here, that is a full, complete cycle. Okay. I'm going to have to scooch out a little bit because I need some more room on this page so we can talk about more things. Dun, dun, dun. Do you want a brain break? Okay, what do you want to do for a brain break? Yeah, what do you want to do for a brain break?
Brain break?
Yeah.
Maybe
We only have like 5 minutes. So maybe we should keep going. Let's just define some things. Okay, a period. Period is the horizontal length of one complete cycle. So as we said for sine theta, actually that's not called sine theta anymore. It's called y equals sine of x, which was what we graphed before. And for y equals cosine of x, the period was 2 pi. And there's a formula we're going to use in the future, which we should definitely write down now. So our period formula is P equals 2 pi over the absolute value of B. And we'll talk about what B is later. But we should definitely have that point in our notes. What?
no.
Calculus.
It's like the lines.
Oh, the absolute value lines. Well, I think you've seen absolute value signs in the past. Yeah. Oh my gosh, yes. Absolutely. Because when you graphed this function, this is an absolute value. So this is y equals absolute value of x or something. It means it can't be negative. Do you need it a different color? Okay. This is the absolute value of b. So this is absolute value of b. Now you know it. Now when I spell it out. Okay, there's also another thing called a midline. Midline. This is the horizontal line halfway between the min and max point on the graph. So midline, which I've now realized you're not going to need in the future for this class, but you will need it in the future for pre-calc. Halfway between the max and min points on a graph. So I'm going to quickly sketch out what sine looked like again. So sine looks like this, right? So sine graph, perfect. So right here is pi, over here is 2 pi, up here is 1, up here is negative 1, over here is pi halves, and over here is 3 pi halves. So my min and max are going to be right here, where it changes directions and starts to decrease in this one, and my min, it starts to increase. So my midline is what's in between. Midline. I don't know what this even said. The horizontal.
The x is the
What? The x-axis, yes. Because the horizontal line halfway between. But you can find this by doing the max plus the min divided by 2, which in normal formulas is going to be your k. We're not really going to talk about k. But this is how you get the min and max. Ooh. That means you got 3 minutes. 3 minutes left with me. And we're going to spell out what?
because you didn't think wait. You should think that.
Okay, how far this goes up, this is called the amplified. Amplitude. Sorry. Amplitude. So, amplitude. I think you have. Which is the max minus the min divided by 2, which is going to be represented as A in our equations. So this is the distance from the midline to the max or min. From the midline, which Yell said was the y-axis. Yep, 100%. X-axis. To the min or max values of the graph. Which in this case was what? What was the distance between the x-axis and the highest point right here? What's the distance from here to here? 1. In any problem, the A is going to represent our radius of the circle. So if I tell you it's 2, that means the radius of our circle is now 2. So represents the radius. The radius of a circle. And that is where we're going to end for today. But we do have homework, right?